Hello. In this video, we'll be looking at the commutative and associative properties of multiplication. So, what is the commutative property of multiplication? Now, this is a bit wordy, but I do want to give you a definition as it is said by an actual textbook. So, according to McGraw-Hill, the definition of the commutative property is that the order in which two numbers are added or multiplied does not change their sum or product. And for any number a and b, a plus b equals b plus a, and a times b equals b times a. So in an easier way to say that, what does it mean? And that means that the order does not matter as long as we are only adding or only multiplying. So in the next examples, we will be looking at only multiplication. So here's 4 times -6, and according to the commutative property of multiplication, the order doesn't matter. We can say 4 times -6, or we can swap or commute our numbers and say -6 times 4. This will give us the same answer. Now let's look at a few examples that will be slightly more complex than this one. Okay, so we have the problem 3/5 times 4 times 15. Okay, so we can just multiply straight across. However, I know my multiplication facts, and I know that 15 is a multiple of 5 and they can be reduced. So I'm going to use the commutative property to swap my 4 and my 15. So I'm going to say 3/5 times 15 times 4. Okay, now to multiply any number times a fraction, I put it over 1. And as I said before, I can see that I can simplify this because 5 is a factor of 15, or we can say 15 is a multiple of 5. But what it means is both of these can be divided by 5. And 5 divided by 5 is 1, and 15 divided by 5 is 3. Now we're going to multiply. 3 times 3 is 9. 1 times 1 is 1. However, we should remember that 1 in the denominator just means we have a whole number, and so it's not exactly necessary to keep. So I'm going to go ahead and erase it back out. Then I bring down what I haven't used yet, which is my times 4. And I get 9 times 4 is 36. So as we can see, the commutative property is all about changing the order of my numbers to make things easier to multiply. So let's look at another example. Okay, here's one. It's a bit more complex, and we do have a few negatives thrown in. So I have -1/2 times 15 times -2/5 times 6 times 6. Well, just like in the first problem, I have a 15 and a 5 in a denominator. I'm going to go ahead and commute those together because I already know 5 and 15 will be able to simplify each other and help me get rid of a fraction. So that leaves my -1/2. And I know that 2 is a factor of 6. So I'm going to commute my numbers around and put my -1/2 with one of my 6's, and then just put the second 6 at the end. Okay, so I'm going to do the same thing. I'm going to put my 15 over 1 to make it into a fraction. I'm going to simplify out of 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So 3 times -2. A positive times a negative is a negative. 3 times 2 is 6. My denominator is 1 times 1. I can put this over 1, but I'm going to leave it out. Now to look at my -1/2 times 6. I'm going to place my 6 over 1. I'm going to simplify. 2 will go into 2 one time. 2 will go into 6 3 times. -1 times 3 is -3. 1 times 1 is 1. However, I'm not going to include the 1 in my denominator. So in case you lost where it went, and then I'm bringing down my extra 6. Okay, now we're going to multiply. I am going to leave them in this order because a negative times a negative is a positive, and I can go ahead and deal with that. So -6 times -3 is a positive 18. Bring down my 6. 6 times 18 is 108. Okay, we can commute them into any order that we want. I am just showing you the fastest methods. You could say, I want to put my fractions together and start with your -1/2 times your -2/5. And then you could do all of your whole numbers. But if we look, the first whole numbers we're multiplying is 12 times 6, and we already know that's 72. Okay, yes, we ended up with a large answer at the end, but we're already at a 72, and we still have to multiply another 6. So when you can simplify out with your fractions, it's a good idea to do so you're dealing with smaller numbers. Let's look at one more example with fractions before we move on to the associative property. Now there's one thing we want to note first, and that's this has a division sign in it. Now according to the commutative property, we have to only multiply. So at first glance, we would say, okay, this is not only multiplication, so I would follow my order of operations. However, in the multiplying rational numbers video, we did talk about keep, change, flip, K, C, F. And keep, change, flip is how we were able to divide fractions. We can take that and we can use it here. So the only difference is that our keep applies to all the other numbers except for the one directly after your division sign. Okay, so I'm going to keep my 3/5. I'm going to keep my times 9. I'm going to keep my times 10. And I'm going to keep my times 3. Okay, now I go on to change. I'm changing division into multiplication. And I'm flipping my 3 over 1 over to turn it into a 1 over 3. And remember, we don't have to keep the 1 in the denominator. It's not necessary. Okay, now I have only multiplication. I'm ready to commute my problem. I have primarily whole numbers, except for this 3 over 5. And so I'm going to pair it with the 10 because I know 5 is a factor of 10. So I'm going to say 3 over 5 times 10 times 9 times 3 times 3. Okay, so let's put our 10 over 1. 5 and 10 can factor out of 5. 5 divided by 5 is 1. 10 divided by 5 is 2. 3 times 2 is 6. Let's go ahead and start multiplying some whole numbers. 9 times 3, and actually I'm going to use the commutative, and I'm going to commute this to the end of the problem. I want to do my 3 times 3 first because I know my 9's times table. So 3 times 3 is 9. Bring down my times 9. Okay, this is spread out a little bit. I'm going to rewrite it over here. So we have 6 times 9 times 9. I'm going to go ahead and commute my 6 to the end of the problem. So I'm going to rewrite it, and then I'm going to erase it. Okay, So 9 times 9 is 81 times my 6. 6 times 81, 6 times 1 is 6, 6 times 8 is 48. So my answer is 486. Okay, so that's the commutative property. It allows us to move our multiplication around as long as we're only multiplying. But if we know how to change multiplication into division into multiplication, we can take care of it then. Now, let's look at the associative property. Now, according to McGraw-Hill, the associative property is the way in which three numbers are grouped when they are added or multiplied, and that does not change their sum or product. For example, for any numbers A, B, C, A plus B in parentheses plus C is the same as A plus B and C in parentheses. Or, for multiplication, A times B in parentheses times C is the same as A times B times C in parentheses. So what does that mean in just plainer English? It's that the grouping of our numbers does not matter as long as we are only adding or only multiplying. And like before, we are looking at multiplication examples. Okay, so as in a very basic example, 1 times 2 in parentheses times 3, we can use the associative property and move our parentheses so that the 2 and the 3 are grouped. Okay, we will look at two examples. So we have 2 times 1/3 times 6/8. So I am going to use the associative property to regroup so that I have the 1/3 times the 6/8 in my parentheses. Okay, so we multiply these first. The 1 and the 6 and the 3 are factors, so we divide them both by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Okay, well, 1 times 2 is 2. 1 times 8 is 8. Now I'm going to bring down my remaining 2. I have to put it over 1. I can still factor out a 2 between the 2 and the 8. 2 divided by 2 is 1. 8 divided by 2 is 4. So I'm left with 1 times 2 is 2. 1 times 4 is 4. I can simplify this further because I know 2 over 4 is the same as 1/2. Okay, so in that, it allowed us to start canceling our numbers earlier because there's nothing similar between 2 and 3. Now for another one, I'm going to change my grouping or who my numbers associate with so that I can multiply my negatives first, and it will give us something easier to multiply the 12 by. So I'm going to change. Okay, so a negative times a negative is a positive. 4 times 5 is 20. Bring down my times 12. 12 times 20. Well, I know 2 times 12 is 240. And then I'm just going to bring my 0 down. So 2 times 12 is 24, and bring down my extra 0. And that's how you use the associative and the commutative properties of multiplication to make your life easier.